Hi, today we will have a demo session on design of cantilever wall in GEO5 software. So to explain this, I will be considering one of the examples from the module and I will be explaining the step-by-step process of design. For that, we will just open the GEO5 from all the modules. We have to select the cantilever wall. So once the module is open, we can see a demo version of that, means a indicative sketch of the cantilever wall with a basic geometry which we can be altered. So as we know that we will have the total interface of this module will be very simple and easy to understand. So the main options of the module will be on the right side, which will be starts with the project details and settings, which will be included with the details of which standards we have to be followed to do the design, and geometry, materials, profile of the location and the soil properties, and type of the fill. So here I will be explaining about the basic interface here on the left side also, which will be having very indicative details. There is no functional requirement of these. Generally it will be like indicative. That means we can select whether 2D or 3D just to check how visually it will be. So to be noted, 3D just is an indicative purpose only. The analysis won't be considered in the 3D analysis. 3D. Okay. So we will start with the project details. So the basic project details we can add here, like what is the project name and the description, who is the customer and author, everything. So here I am just writing as demo 01. After that we can have the select settings option, where we have to select the which standards we have to be considered. Here we can see the select setting options. Here we can go and check the whatever the options we have. Here we have standard, factor of safety, limit state, design approach 1, design approach 2, design approach 3 as per Euro codes, and the other standards also. For this demo session, I will be considering the standard with safety factors. Next, I will be moving to the next option, geometry. Here, these are the typical geometries of a cantilever wall generally. So here we can see all the shapes and all type of combinations will be there. Only the thing we have to give the specific dimensions of each and every element of this. So I'm just considering one of the simple geometry of a cantilever wall, and I will be considering the dimensions like K. Here we can see thickness of the wall, and H is nothing but height of the wall, all these details. So I will be considering the thickness of wall as 0.4 meters and height as 4 meters, and thickness of the foundation as 0.4 meters. V1 is nothing but projection on the right side as 0.4 meters. Projection on the left side is 0.4 meters. Projection on the right side is 1.7 meters. So here we will now we can see the whole geometry what we considered. Now we will move to the material option. So now we will move to the material option. Here we can see we can give the what is the unit weight of the wall As of now, I'm considering 25, which will be equal to the unit weight of the concrete. And I'm taking the concrete catalog as C2025 and longitudinal reinforcement as B500B. So after that, we'll go to the profile where we can add the layers here. So I'm considering top 4 meters as one layer, which will be followed with another type of soil. So that means here I'm considering the two soil types. One is from top of the retaining wall to the 4 meters. The remaining is with another. So now I will be considering the soils. So first soil is like it's a type of soil which will be having a unit weight of 17.5, and considering the stress analysis as effective and angle of internal friction 28, cohesion 0, angle of frictional, that means angle between the soil and the structure, considering 18.5, pre-stress at rest, cohesionless soil, uplift I'm considering standard and unit weight of the saturated soil as 18. So here we can select the color coding of this. So here I'm considering the yellow color just for identification purpose. And the second layer I will be extracting from the classifying, that means where we can get the standard properties of the soil. Here we can see what will be the properties will be in the approximate range which will be matches with your standard properties of the soil. So I'm considering sandy silt and I'm exporting these properties and add. So yeah, so these two soils are assigned here. Sorry, I forgot to give the color coding to the second soil. I will be considering some violet color. That's it. Okay. Yeah. So now I will be assigning the properties of the soils. For the first layer, it is SF type of soil. Second layer, I will be considering sandy silt. So after this, we can go with the backfilling. Which type of backfilling we have? So as of now, here I will be considering the vertical, that means there is no backfill, considering the another transition material adjacent to the cantilever wall, so I'm considering none. And in terrain, I'm considering a simple terrain, that means there is no soil sloped from the top of the cantilever wall. So here I will be considering this first option. Here we can see the other options based upon the requirement and based upon the existing terrain. We can consider any of these and we can give what is the height of that soil. Next will be the water table. So here I am assigning a water table at approximately 2 meters from the top of the wall, so that it can be considered the water pressure also on the cantilever wall. So, so from here top of the wall it is 2 meters. After that, have to consider some surcharge, where one type of surcharge. We can say it as a surface load or strip or horizontal point line or horizontal, sorry, trapezoidal or horizontal. Here I'm considering the strip type of loading, considering the permanent condition, location on terrain up to the length of 5 meters with an intensity of 10 kilonewton per meter square. So now we can see this. Here we can see the surcharge load is assigned at the top with 10 kilonewton per meter square intensity. Now we will move to the fifth resistance, that means the tail resistance on the other side. I'm considering some passive resistance on the other side. Resistance type at rest, but I'm not considering as of now. That means I'm just assigning the existence of the soil, but I'm not considering any of the resistance offered by that soil in the analysis. And what type of soil it should be, I'm considering the same soil on the right side, whatever, up to the height of 1 meter. Now we can, here we can apply some forces when if we have some vertical point load or horizontal forces. Here we can add that. Now I'm just moving to the staged sections, sorry, stage settings. So here I'm considering the design situations as permanent condition, pressure acting on the wall as active pressure, reduction of the soil frictional angle, I'm considering at rest. Sorry, pressure at rest on the stem. So here we can see the reduction of the soil or soil frictional angle. I'm not considering any reduction. I'm considering the same value throughout the height of the retaining wall. Now we will move to the analysis part, that means verification. Just, yeah. So when we press on the analysis part, that means if we want to do some slip circle, that means slope stability analysis of this, here we can click on the analysis, so it will be redirected to the slope stability module where the geometry everything will be imported from there directly, and you can run the analysis and you can check whether it is stable or not. But for this you should have the slope stability analysis module also. So just for rough consideration, I'm just checking whether the stability of that retaining wall is okay or not. After that I will move to the other options of the module. So as we discussed earlier, here the method of the analysis is considered as the Bishop's method, and analysis type is optimization, which will be given the worst, that means critical slip circle of that location. And here we can see the factor of safety is 1.91, which is greater than 1.5, and the stability is okay, that means it is safe. Now I will just close. Before just closing it, I will just say exit and save. That means the analysis will be saved at the background. That means the stability analysis also done. But here we can see the overturning is satisfactory, but the slip is not okay. That means the end bearing, the resistance of the and bearing is not okay. Now we will go to the geometry and modify slightly the geometry of the retaining wall. Yeah, here I will be considering with this, that means we will have some small anchoring into the soil at the bottom, which will be give a better stability to the foundation of the cantilever wall. So here I am just making it as a height as 3.6 meters height, x is 0.4, 0.4, 1.7, and x1, that means the thickness is zero point 0.8, x2 0.4. I am just making slight modifications in the geometry so that it will be stable. So not only this option, we can go with the any of the option, because based upon the failure what we are having here, we can see very clearly it is a slip failure. That's why I'm just giving some anchor at the bottom, so that the slip, it will give some resistance, which will have some resistance at the bottom, which will avoid the slipping of the foundation. Now I will go to the, sorry, yeah, this is already done. Yeah. So after modifying the geometry, now we will check the stability. So we'll go to the verification. Here we can see it is safe under overturning and slip also. Here we can see the percentage also, nothing but what is the resistance we are having. Now we will be checking the bearing capacity, that means bearing capacity at the bottom. Here I'm picking up the option of input bearing capacity of the foundation soil. If we don't know the bearing capacity of the foundation soil, then we have to run the analysis in the bearing capacity module for the spread footing, and from there also we can get the values into the cantilever module as an input. So here I'm just considering directly the value somewhere around 17.5 kPa, and stress in the foundation bottom I'm considering as a rectangular, not the trapezoidal. Okay, now once we enter the bearing capacity, sorry, there's some typo, 175, yeah, yeah. Here in bearing capacity we can see the foundation soil is satisfactory. Now here we can see what is the bending moment and shear force of the cantilever wall also. Yeah. Here we can see the bending moment and shear force of this cantilever wall, what is the minimum and maximum, and here we can see what is the reinforcement also, with cover 30 mm, number of bars 5, die of the bars as 20. So with this we can check the stability of this by it will be rerouted to the slope stability module as we discussed earlier, and now we can check the stability and run the analysis, and we can check the stability. Once it is safe with the factor of safety, the all the checks are done. That means overturning, slip, that means sliding, bearing capacity, wall stem check, and overall stability. So with this, yes, it is 2.23, which is greater than 1.5. It is safe and it is stable. So with this, we can conclude that the cantilever wall is done, design is done with GEO5. Thank you.